Hi, so I'm doing this video to try and help people with deciding what method they should use when integrating. You can see I've got four integrals written here, which I'll come back to. I'm just going to use a different set of four to show you how to choose which one would be which, and then we could try and match these together and then perform the integrals later on. Okay, so here we've got four integrals. I'm going to explain which one will be which. So if we was to look at this first one here, this is the type that would be by inspection. So what you could do with this first one is you could imagine that the power would increase by 1. So you could actually make a guess, and then upon making that guess, you would then differentiate that guess and compare it to what you had originally. And you can just adjust the scale factor on the front so that it matches accordingly. So I'll show you what I mean. This is also called the reverse of the chain rule. Okay, so if you understand how the chain rule works, then this becomes really easy. This is what you'd also call a composite function. So that's what you're trying to spot here. For example, f of x to be 3x plus 4, and if we had g of x to be x to the 5, then if we did gf of x, it would actually be 3x plus 4 to the power of 5, which is what you see there. So this is in fact a composite function. And if you see a composite function, we differentiate that with the chain rule, and the reverse of the chain rule is in effect by inspection. Okay. So what can I do? Well, what I would do is I would make a guess, which would be that it's going to be 3x plus 4 to the power of 6. And if I differentiate that guess with respect to x using the chain rule, I will get, so it'd be the 6 coming down multiplied by the 3, which you get from differentiating that bracket there. 3x plus 4 and power of 5, I end up with 18 at the front. And as you can see, I actually didn't want an 18 at the front because there's no 18 there. So what I then do is adjust this so it has 1 over 18 at the front. So that now gives me what I need. Let me just write that a little bit nicer. And the easy way to spot this is simply thinking that if the power increases by 1, that becomes a 6 power. We have a 3 next to our x there when we differentiate it. So if you multiply those together, it gives you 18. And you can just think of that as being the denominator, since when we integrate, you have to do the reverse. Okay? So there we go, that one's that. These three here, this one here, you can see is a product of two functions, so that one will be by parts, since the by parts formula comes from the product rule. So if you ever see any products, then by parts, and you can actually see the by parts formula is in the formula book there. I don't personally write it in that way, but as you'll see in a minute. Okay, so that's by parts. What else do we have? So we've got 2 and 4 left. Now one of these is what we call a standard integral. So if you was to look in this formula book, we actually have some standard integrals. And so that one would be this one here. In this case, that a is 1, okay? So if you think about it, you could think of that as a 1 squared. So in fact, a equals 1. And if that's the case, then it just simplifies to the inverse tan of x. So that integral is just the inverse tan of x plus c. Okay. So standard integral, that one. And number 4, therefore, would be by substitution. But let's talk about why. Okay. The reason it's by substitution is because you will see that we have this function here, and if we was to take its derivative, it would be 2x, and that is exactly what you see written in front. So if you see a function within an integral and you also see its derivative next to it, then that implies it's by substitution. And another thing that I look for is just general complexity. So you can see that if you look at all of these, this one does look the most complex, and it has this part here which is the complex bit, and this is the part you would set to be u. Okay, so I should go ahead and work out these other two integrals just to show you, and then we'll take a look at the original set. That definitely does not want to go. So yeah, let's just do the product rule first, which is pretty quick. So that would be the integral of v dash with respect to x gives me uv minus the integral of vu dash dx. U in this case I'm going to be setting as x. The derivative would be 1. V dash would be my cos x, and v therefore is the integral of cos x, which would be sin x. And so this goes to uv first, which is x sin x, and then take away the integral of vu dash. U dash is just 1, so it's just the sin x. The integral of sin x goes to minus cos x, but since we have a minus sign here, that will just be positive, and so it's just plus cos x plus c. So that one was the product rule. Remember, number 2 was the standard integral. Number 1 was by inspection. And let's do the last one by substitution. So we're saying we're going to set u equal to x squared plus 2. That's where the complexity is. If we take the derivative, we get 2x. Okay. And rearranging for dx is du over 2x. And it's nice because what you notice is when you take the derivative, it's actually there at the front. That's a big giveaway. You will see here when I substitute in for dx here, that whilst the 2x is in the denominator, it will cancel out that one there. So that's why you always look for its derivative. So if I was to substitute in there, I've got 2x here. This is now just going to be written as u to the power of 4. And dx is going to be du over 2x, which nicely cancels that out. So it's just the integral of u to the 4, which is u to the 5 over 5 plus c. If I sub u back in, which is here, that gives me x squared plus 2 divided by 5 plus c. Okay, so there they are, the 4 methods. So why don't you pause the video and see if you can figure out which method is for which. Okay, so let's have a go at working these out. So let's do these in order, why not? So we've got by parts first. So we're looking for a product with by parts. And not just that, there's another thing. We're looking for where when you differentiate one of the functions, it will end up simplifying the second integral in by parts. So you might say, well, there's a product here between these, which is true. This one doesn't really have a product, it's just one function. This one doesn't have a product, so it's either the top or the bottom one. Now, one of those is substitution. It will be the top one because the top one has a lot of complexity within its integrand. And also, if you notice this bracket here, if you was to take this derivative, it would give you 3x squared. And that's exactly what you see here at the front. Okay? So, this top one would be substitution. So that must mean the bottom one is the product rule. And another giveaway for this being the product rule is the fact that you see an x here. If you was to set u equal to x, then when you take its derivative, it goes to 1. So why does that simplify the integral? Because the product rule allows you to get uv straight away here, but then you have to integrate v u dash. So if you think about this, if u dash is 1, that means that would be a 1. And so you're only integrating v. So there's no longer a product within that integral, if that makes sense, okay? So that's why that one's the product rule. So we've just got 2 more to worry about. So one of them's a standard integral. So it's 1 over the square root of 1 plus x squared. If I was to take this, you would see that that would be this one here. Okay, so it's actually the sine x standard integral. Okay, so you can just quote the result, and here a equals 1 again. So that makes it quite nice. So if a equals 1, that means it just goes to the inverse sine x plus c. So that one's pretty simple. Done straight away. So we said that the top one's by substitution. We'll leave that for a minute. But this one here, therefore, must be the by inspection, or reverse of the chain rule. And you can see that here because it's a composite again. You've got a function inside the bracket, and then you've got something acting on it outside. So it's just like having a function inside here, and then a function outside acting on that. So it's a composite. So here we can just make a guess for that one. So I'll guess 2x plus 5 to the power of 6. And then if I differentiate this with the chain rule, I'll get 6 times the 2 from differentiating that. 2x plus 5 with a power of 5. So it gives me a factor of 12 at the front, which I don't want. So that means I just need to divide this by 12. Okay. So that one can just be done by guessing, essentially. So the top one's by substitution. I'll have a go at performing that now. So it's the complexity within this bracket that's the bit you want to set as U, because this is being acted on by the power of 5 as well. So that gives us as du is 3x squared dx, and therefore dx will be du divided by 3x squared, which will cancel that out the front. And so I can rewrite this as being the integral of, let's write 3x squared here, and then I've got u to the power of 5 now. And dx is going to be written as du of the 3x squared, sorry. Cancel those. And so it's just u to the power of 5 du. And then that's just u to the 6 over 6. And then just remember what u was, x cubed plus 3. So there you go, okay? Last one is the product rule. Let me just rub that out. There's the product rule there. We've already said a little bit about this. So, integral of x e to the x. We've got u first, which is x. V will be the integration of e to the x. So we're going to set this one as v dash. So v is the integration of e to the x, which goes to itself. So that's x e to the x. Take away the integral. V again is e to the x. U dash is actually 1. So you can see that's where it's simplified, the integral. So that clearly goes back to itself again. And we can factor out e to the x if you want. There you go. So that's the answer. Right, so that's the 4 integrals done, and a little bit about how to spot them. I'm going to do another video coming up after this one, which will go through a vast number of integrations, one after the other, and I'll go through it at quite a fast pace. I'll just try and get you in the habit of trying to spot how to work out what integral is which. Thank you very much. Please do like and subscribe if you found this helpful, and feel free to drop me a comment. I absolutely love it when people engage. Thank you. Have a nice day.